Happy New Year to all residents of planet Earth. I should let you know that the calendric New Year, January 1st, celebrated sequentially in 24 time zones around the world. That is kind of odd. We celebrate the moment of midnight, but that moment is an hour earlier than the folks west of you. Okay, that's a little weird. To put so much focus in a moment in time that no one else cares about until that moment in time happens to them. So anyhow, all humans on Earth take 24 hours to celebrate the new year, and that's one of the celebrations of the year that has no astronomical relevance, significance, or importance. It's completely made up. And that's okay, but I just thought I'd let you know that. Do you like sunsets? Everybody likes sunsets. Here's how to create a permanent one in your life. Get on a fast jet when they can go 800 miles an hour, and then fly due west right at sunset. And you know what you'll do? You'll be chasing the setting sun over the rotating Earth, because you'll be flying west at exactly the rate that Earth is rotating east. And you'll cancel out the rotation of the Earth, leaving the sun parked on the horizon for your view. I got one for you. So, you may know that Earth satellites, the low orbiting kind, a couple hundred miles up, complete one trip in 90 minutes around the Earth. Okay. You know what also takes 90 minutes? If you drilled a hole through Earth, all the way coming out the other side, and you jumped in it. So if you jump in, you'll accelerate, you'll overshoot the middle of the Earth, come out the other side, take a look around, and you'll drop back through, returning to where you began 90 minutes later. So if you sent a satellite off to one direction and you jumped in the hole, you will both return to the same place at the same time. Northern Hemisphere, we're in the midst of winter. And people think of winter as being dull and drab and dreary and cold, depending on your latitude on Earth. And I don't think about it that way, because every day of winter has slightly more sunlight than the day before it. So the winter months are, if you date it from the winter solstice, December 21st, each day shows more and more sunlight. And so for me, that's hopeful. It's summertime where you're systematically losing sunlight. So if people say, oh, the days get longer in the summer and shorter in the winter, the exact opposite is true. If December 21st is the shortest day of the year, first day of winter, then every day after that has to be longer, doesn't it? And if June 21st is the longest day of the year, every day into summer has to be shorter. Yes, NASA did recently discover water on the moon where they didn't expect it. The moon is so hot, and by the way, the whole moon gets sunlight in a month, by the way. A day on the moon lasts a month, okay? So the whole moon gets sunlight, and most of the moon is too hot to sustain water at all. The water molecules just evaporate and escape into space, actually. What we found was near the poles, where the sun's intensity is not very great, you can find water scattered on the surface in addition to where we knew you could find water, which was in the deep craters on the poles that have crater rims, where the sun's angle will always cast a crater rim shadow in the bottom, at the bottom. And forgive the expression, is where the sun don't shine. So again, these are water molecules. You're not going swimming, you're not going ice skating. It turns out that famous speed limit imposed by Einstein's special theory of relativity, the speed of light, that applies only to sort of material objects moving within the pre-existing space. But space itself can expand, carrying objects with it in that expansion at any arbitrarily high speed. Precisely what happened in the early universe. The first few moments of the universe, we expanded faster than the speed of light, and with dark energy, as this pressure forcing an acceleration on our expansion, the edge of the universe is going to be expanding faster than the speed of light no matter what. You can't see that, you can't interact with it, because the light it's sending back to us will never reach us. So, yeah, if you do expand faster than light, you're gone. You're still there, but you're gone. Just saying. Who knows what NASA stands for? It's a word, an acronym, okay, an abbreviation that spells a word that you can pronounce. All right. So NASA, National Aeronautics and Space Administration. That first A is important. One of NASA's mandates, which you never hear about, is that it studies the movement of aircraft and other objects through air. That's what aeronautics does. So NASA not only builds things that move through space, they build things that move through air. And they do that with wind tunnels and simulations of airflow. In modern times, you can just put it on a supercomputer. You don't necessarily need physical objects in a wind tunnel. But the point is, there's a dual mission of NASA. The average life expectancy of a mammal species is several 100 million years. And we've been around on this earth in our current form for just a few 100,000. So we have many more millennia to look forward to. But if you want to outlive the sun, and we want to live for billions of years, that's going to take enlightened governance. You know, if Earth rotated once in 90 minutes instead of once in 24 hours, then the centrifugal force at the equator would be so high that everyone there would just be floating above the surface. That'd be cool.